Let's practice working with literal equations. You know that an equation is formed by a set of expressions that are equal to one another. In equations, you often have variables that represent unknown amounts, and you can use the equation to find the value of the variable. You've also probably learned how to solve one and multi-step equations for a single variable, and in this case, we're just going to be talking about literal equations, and there's a slight distinction here. So I've written the definition. A literal equation or literal equations are rules or formulas where there is more than one variable. And let me give you an example. Here's the formula for speed. Speed equals distance divided by time. And as you can see, there is more than one variable here because you're dealing with speed, distance, and time. Let's just say you wanted to solve for time instead, and you know the speed formula. How would you do that? Well, treat it like a variable that you're trying to move around an equation. So here you notice that time is in the denominator of this fraction. So if you want to get distance by itself, time is being divided, so the inverse operation of division is multiplication. So you'll multiply both sides by time. What happens on the right side of the equation is that time cancels out with time in the denominator, and you're left with speed times time equals distance. Now let's say you wanted to solve this equation for time. Notice that speed is being multiplied by time on the left side. To get speed to the right side of the equation, apply inverse operations, so divide both sides by speed. And if you do that on the left, that's what you have, and you're going to divide that by speed as well. Now on the left side, speed is going to cancel out, and what you're going to be left with is time equals distance divided by speed. Now what we did was we took this first literal equation that was solved for speed and we algebraically manipulated it, and we got to speed times time equals distance. So now you solve for distance, and if you wanted to solve for time, we took that one step further and solved for time. And this is how you can manipulate literal equations. Let's try a problem together. A can of beans has a base radius of 3.5 centimeters. If its volume is 770 cubic centimeters, what is its height? All right, let's keep track of this information. So I like to draw on a little figure here. I've marked the radius of the base, and this has a value of 3.5 centimeters. Now you know the volume of this entire can is 770 centimeters cubed, or cubic centimeters. So you need to remember the volume formula for a cylinder. The volume of a cylinder equals the base area times the height. Now the base of a cylinder is a circle, and if you recall, the area of a circle has the formula pi r squared. So I can substitute that into the equation. So now I have pi r squared times the height, which I'm going to represent with the letter h, and this is equal to the volume of the cylinder, which I'm just going to use a v for. Now substitute in the values that you know. You know the volume is 770 cubic centimeters, and I'm just going to work with the numbers and we will come back to the units later. So 770, that's the volume, equals pi, that's a constant, and now you have r squared, so radius squared, and you know the value of that, it's 3.5, so pi times 3.5 squared times h. And h is what we want to solve for. So what we're going to do is manipulate this expression so that we can solve for h. To do that, notice that h is being multiplied by this term here, pi times 3.5 squared. Now you can treat this entire thing as one term, and if it's being multiplied by h, the inverse of that is dividing. So you're going to divide both sides by pi times 3.5 squared. So you get 770 divided by pi times the radius squared, and this is equal to pi times 3.5 squared over pi times 3.5 squared times h. These cancel out to 1, so you're left with 770 divided by pi times 3.5 squared equals h. And let's just make some more space for this math work we have to do. So I'm going to rewrite this you get 770 over pi 3.5 squared equals h. Now, you want to expand the exponent here, so 3.5 squared. So what I've done is move the equation up here, and now you have pi times 3.5 times 3.5, because 3.5 squared is just 3.5 times itself. Now the other thing you need to know is that pi has an approximate value of the fraction 22 over 7, and if this were a decimal, you could work with pi as a value of approximately 3.14. So I'm going to substitute that value into the denominator of the expression. And now I'm going to simplify this even further by saying that 3.5 goes into 7 two times. So I'm going to cancel out one of the 3.5s here, which will leave me with just 2 in the denominator. So I have 22 times 3.5 divided by 2. So the next step is to divide 22 by 2, which has a quotient of 11. So this simplifies to 70 over 22 divided by 2, which is 11, times 3.5. And this is all equal to h. Now I'm going to erase some of the work over here on the left that we did and make room to continue solving for h. 11 times 3.5 equals 38.5. So let me just replace this denominator now with the actual value. So you have 38.5. So now to solve for h, divide 770 by 38.5. And when you do that, you get a value of 20. Now remember, all of the measurements were in centimeters, so that means the height of the cylinder is 20 centimeters. Thanks for watching.